Welcome back, student, to this part where we need to find the curvature of a vector-valued functions. So we start with example 8. In example 8, the question is we need to find the curvature using the formula for the curvature for the vector-valued function r of t equal t squared j plus t cubed k. So just let me remind you first of all of the vector for the curvature for vector-valued function. So the curvature k is given by the magnitude, the norm, the length of the derivative of r, cross product the second derivative of r, and then we divide by the derivative of r power 3. So this one here is the formula for the curvature. So what we need to do, we need to find the first derivative, second derivative, and then we need to find the cross product, and then we apply it in this formula. And then of course we need to find the magnitude of the numerator, magnitude of the denominator to the power of 3. So let's start solving this question. So as I said, the first thing is I need to find the derivative. The derivative will be 2tj plus 3t squared k. That is the first derivative. I will also need the second derivative, which will be just 2j plus 6t k. Next step, which is the most important one, is we need to find the cross product using the formula of the cross product. So please, you can watch the video about the cross product and how we find the cross product of two vectors in R3. And the idea is that we will use I, j, k in the first row. In the second row, we will write the component of the first vector, which is 0, 2t, and 3t squared. And next, we write the component of the second vector, 6t. And then we start expanding using one vector at a time. So the first one is we will expand on the first item, which is I. We cancel the row of I, the column of I, and we find the determinant of whatever left. So the first one will be something in I. And what is in I? We cancel the row of I, the column of I, and whatever remaining, we need to find the determinant. The determinant of this one is just a times d minus b times c. So if we do it, it will be 12t squared minus 6t squared minus, and then the coefficient for j plus the coefficient for k. How we find the number in front of j? We cancel the column of j, the row of j, and we find the determinant of whatever remaining, because this is 0. 0 times anything is 0 minus 3t squared times 0. Again, this will be 0. So there will be nothing in the direction of j. And finally, for the k, we'll get the same situation, 0 minus 0. So again, we'll get 0. And the final answer will be 6t squared I. That is the product. Now, all what remains to find the curvature is to find the magnitude. So for the formula for the curvature, it is the magnitude of the cross product, which we just found, over the magnitude of the first derivative power 3. Now the formula for the magnitude, let me just remind you, it is the component, each component square inside the square root. Now since we don't have I and j, the component are 0, so I'll fill those with 0. And whatever in front of I will fill it up here. So I will get 6t squared, 0, and 0. Let me try simplify this one. So it will be just square root of 6t squared squared. And of course, the square root and the square, they will cancel each other. We will end up with the absolute value of 6t squared, which will be, after all, exactly 6t squared. And the reason why is because it is already positive, so I don't need the absolute value. But if this was, for example, only t, then I have to keep the absolute value because maybe the curvature is plus or negative, depends on the value of t. Now for the denominator, we'll do the same, but here we'll have to be careful because there is power 3 to the top, and then we find the magnitude of the first derivative. So we go to the first derivative and we just write the number. The first one is 0, the second number is 2t, and the third one is 3t squared. I get them from the first derivative. So this 2t will go here, 3t will just be here. And now we continue. Again, we keep the cubic root and the square root. If we simplify this one, this is 4t squared plus 9t power 4. We cannot really simplify it anymore. I prefer we just keep it as is. So, and that will give me, this is the final answer here. 4t squared plus 9t cubed. And that's the answer for the first example. Of course, if we know the value for t, we can substitute it and we find the exact number for the curvature. But in general, this is the general formula for the curvature in this example. We go to the next example and we will do exactly the same procedure one more time. If you look at example number 9, of course, I would prefer you pause the video and try to do it yourself. And this curve is one of the familiar curve. We call it the twisted cube. We have seen this curve before, and it's given by t squared, and t cubed as the components. So we'll do the same idea one more time. Remember that k is the first derivative cross the second derivative over the first derivative to the power of 3. That's the curvature, the formula. We'll keep it in front of us. And next we need to find the first derivative, which would be just I plus 2tj plus 3t squared k, just the usual derivative. And we need to find the second derivative, and then we'll find the cross product. So because the I has no t, it will be 0. So I will just left with 2j plus 6t k. Next is to find the cross product. The cross product. Again, in the first row, we write ijk. In the second row, we write the component for the first vector, which is 1, 2t, 3t squared, and then 0, 2, 6t. Now, if we expand this one, I'll do it a little bit quick here. If we expand this one for the I, it will be 12t squared minus 6 squared. So that's it, what it will be. So here it will be 12 minus 6, it will be 12t squared. Sorry, it will be 12 minus 6, so it will be 6. Next, for the j, we cancel the row of j, column of j, and we find the determinant, it will be just 6t. And finally, we cancel the column of k, the row of k, and it will be just 2. That's what we will get for the cross product. Of course, if we want to find the k, the curvature, we just need to find the magnitude of the cross product that we just found over the magnitude of the derivative to the power of 3. So the magnitude for the cross product. Remember, we just have to put everything inside the square. Same thing for the magnitude for the derivative. If we do it, it will be 6t squared minus 6t and 2. And for the derivative, it is 1, 2t and 3t squared. We try to simplify this one as much as I can. We'll do it quickly here. So the square root would be here. The first one will be 36t power 4 plus 36t squared plus 4. And in the denominator, it will be the cubic will stay here. It will be just 1 plus 4t squared plus 9t power 4. And that is the formula for the curvature, for the twisted cube. Of course, if we have the value for t, we can find the answer. For example, if we want to find the curvature, at the point 0, 0, 0. Of course, if we want to find the curvature at this point, we need to know what is the value for t. Now remember, this is x, this is y, and this is z. Now, how much x? X is exactly my value for t. So this means I will only need to find k of 0. Why k of 0? Because this is t equal x equal to 0. Now, if we plug in 0 all over those, this will cancel, 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 cancel. So what we will get down here is only 1, and here square root of 4. So the answer will be 2. It means the curvature, the bend, will be 2 at the point 0, 0, 0. And that's example number 9. Move on to example number 10. So again, I prefer if you can please pause this video and try to do this example. This is a very famous example. It's the circular helix. And the answer might surprise you. So please pause this video, try to find first derivative, second derivative, cross product, and then find the magnitude. Okay, we are back here. Let's solve it together, and then we will compare our answer with your answer. So first, we need to find the first derivative, which is, it will be minus sine t I plus cosine t j plus only k. Second derivative will be minus, it will stay, derivative of sine is cosine. Derivative of cosine will be now minus sine. And because there is no t here, so we have to stop. And then we will find the cross product as usual. So what is the cross product between the first derivative and the second derivative? Again, we have I, j, and k. Here we have to write minus sine t, cosine t1, 0, minus sine t, minus cosine t. And we have to expand this one. So I will expand it, and let's do it step by step. So if we want to find the coefficient of I, we cancel the row of I, column of I. So what we will have cosine t times 0, which is 0. So it just would be 0, minus minus 1 times minus sine, so it will be minus sine t. So in short, the first component will be sine ti, because negative with negative give me the positive. Next, we need to find the coefficient of j. We cancel the column of j, the row of j, and then we do the same thing. We get 0 times minus t, so it will be 0, minus 1 times minus cosine, so it will be cosine t. So the second one will be minus cosine t, which is, if we simplify it, this is minus cosine t j. Plus, finally, let's see what will happen to the k. We cancel. So we multiply minus sign with minus sign. This will give me, of course, sine square t minus. Next, we multiply cosine, because we cancel the column of j, the row of j. Multiply cosine by minus cosine. This will give me minus cosine square. Now, if we notice that we have negative, negative, this will be plus. So here I can just erase this and write plus. Well, sine square plus cosine square, again, we all remember this is just 1. So it will be just k. And that's the cross product. The final step here is we need to find the curvature. And the curvature, the formula is we take the first derivative across the second derivative, which we just found. We need only to find the magnitude over the magnitude of the first derivative. So here we have square, something square, something square, over same thing down here, square, square, square. So only we need to fill them. This is sine t, this is minus cosine t, and this is 1. Down here, we need to go to the derivative, which is minus sine t, cosine t, and 1. Almost, they are exactly the same, actually. Exactly the same. Now, if we do it, what we will get, we'll get sine square t plus cosine square t plus 1 over the same quantity, but to the power of 3. Now we know how much is sine square plus cosine square. This is 1, so 1 plus 1 is 2 over 2. If we do this one, the answer is half. And why I said at the beginning of, before I solve the example, why did I say this might surprise you? Because remember, we would expect the curvature to change based on the t, but no, it is always the same regardless of the value of t. So remember, the helix look like this, like a spring. And at each point, up or down, the curvature, the bend always half, which makes sense because, again, it's a circular going on the same curve, same bend everywhere, whether it's down or up, shouldn't be actually based on the value for t. That's what the intuitive idea for the circular helix is. Next and final example in this part is the curvature k for this curve here. Well, again, we don't have much options to do here. We just have to find derivative, and it will be 1, 3t squared, 0. Second derivative will be 0, 6t, 0. We need to find the cross product, which is 1, 3t squared, 0, 0, 6t, 0. And we need just to find I, j, and k. So what is the coefficient for I? Would be 0. Coefficient for j would be 0. Coefficient for k would be just 6t. So the final answer is 6tk. All what we need to do next is to find the curvature, which is the magnitude for this cross product here over the magnitude for the derivative. The magnitude of this one will be 0 squared plus 0 squared plus 6t squared over, if we do this one, it would be 1 squared plus 3t squared plus 0 squared. Okay, the top one is square root of 6t squared. The bottom one will be 1 plus 9t squared. Of course, square root of, here is 36. Square root of 36t squared, the answer will be absolute value of 6t, and that's the important. Because remember, square root of t squared, it could be absolute value of t, and depends on the value of t, the curvature can be positive, negative. Of course, the answer always will be positive here, regardless of what we need, and that's, we need the absolute value. Without absolute value, the answer could be negative. It shouldn't be negative. Curvature, it will just measure for me, give me a number of the bend. And that's why we keep the absolute value. We need the absolute value. The t could be negative, but the final answer must be positive. Thank you very much for watching. Please share